Hello everyone. Today we will study the chapter 4 of NCERT, that is motion in a plane. When we are talking about plane, that means we have to consider different directions, right? So we will have to recall the concept which we have studied in class 9, that the types of physical quantities can be divided into scalar and vector. Right? I'll just quickly sum up. Scalars may we have magnitude only. Here we have magnitude plus direction. Right? Now here we can add the scalar quantities by simple algebraic addition. But in case of vector quantities, we need to use some special rules of vector addition, right? So those we will study in this video only. So we have to follow vector laws of addition are applicable, right? Then we will have to consider the types of vectors. So if we talk about the types of vectors, we have polar vectors and the axial vectors. In case of polar vectors, the vectors having some starting point. For example, velocity, displacement, etc. Now, axial vectors, these are related to rotational motion, and their direction is along the axis of rotation. Right? For example, angular velocity. And their direction is given by right hand screw rule. That means if we have this right hand screw like this, right? So this is the sense of rotation. So this will give the direction of axial vector, right? So this is about the types of vectors and the types of quantities. Now we'll discuss some important concepts which are related to vectors, right? So first concept is, we are talking about important concepts. So first is position vector, right? If we are given a point whose coordinates are given, we have studied in mathematics, if you have a coordinate plane, xy plane, and if this is the point P, right? This is origin O. If we join these two, then this vector joining the point P is called as position vector of point P. So what is OP vector? This is how we represent a vector. OP vector is the position vector, right? Now, before we discuss these concepts in detail, we must First here only, let's discuss a few points. Representation of a vector. Is by an arrow. So the head gives the direction, this length gives the magnitude, right? And if we represent a vector physical quantity, that we represent it by an arrow above that quantity. So a quantity represented with arrow above it, this is called a vector quantity, right? So this is about this representation. So that means here we can say that OP is the position vector of point P, right? Now let's discuss another case where we have 2 points, right? So if we talk about this, then we can talk about displacement vector also. So that means if you have an XY plane, right, and you have point P, and this is point Q, right? This is origin. So if we join these two, these will be the position vectors of point P and Q. And if I want to find the displacement vector, right? So this is, suppose the particle moves from point P to point Q. Then this vector will represent the displacement vector. How? If we say that this is the R1 position vector of point P, this is the R2 position vector of point Q, P to Q, this is the shifting. So I represent this vector by delta R vector. So PQ is the I will tell you how to calculate the displacement vector later on once we are clear with the other concepts also, right? So then after we have multiplication of a physical quantity by multiplication of a vector quantity by a real number, right? So multiplication suppose I have a vector A vector, right? And I multiply this vector by 2, right? So 2A vector, how will I draw the 2A vector? 2A means 2 times the magnitude of this vector, twice the magnitude of A vector, and the direction same as the given vector A vector. So you can say when we multiply a vector by a real number, the direction remains same, but magnitude becomes real number times, right? So this way, if you multiply this A vector by 2, the magnitude will be 2 times of this magnitude of A, but the direction will remain same as the direction of A vector, right? Next we have addition of factors. Now for addition of vectors, we have to remember one concept. For addition, whatever vectors are given, we attach the head of the first vector with the tail of the next. Similarly, the head of the second vector with the tail of the third, and so on. Suppose we are adding two vectors A and B. This is A vector and this is suppose B vector. I have to add these two. As I told you the concept, I will take this length here, right, and same direction. So if this is the length, this is the length, the direction same. So this is my A vector. I have as it is kept it here. Then I'll pick this B vector, keep it here with the same direction. So this will be B vector, right? So when I will add this, the addition of these two will be the resultant, right? So the resultant will be this closing side taken in reverse order. Taken in reverse order means we were taking this vector like this, B vector like this. So the third closing side will be taken in reverse order. So this gives you the resultant is equal to A vector plus B vector. Now we'll consider subtraction of vectors, right? So we have subtraction if I have to subtract the vector B from A vector. Suppose I have this vector A vector and I have this B vector. So I have to subtract this. Now this can be written as A vector plus minus B vector. For this, we must understand what do we mean by negative of a vector. What is negative of a vector? It has the same magnitude but opposite direction. So that means if I have this B vector, then this will be minus B vector. Direction is opposite but the magnitude will be the same. So I can write this subtraction like this, A plus minus B vector. So this can be written as it is A vector, right? And I have to write minus B vector and then I'll add it. So minus B means I'll simply change its direction. This will be minus B vector and I have to add these two. How to add? We know that we attach the head of one with the tail of the other. So head of A vector and tail of minus B vector will give us the resultant like this. So this resultant is A vector minus B vector. Right? Hope this is clear. Then we have different laws of vector addition. No, before that we will study what is a unit vector. So this is clear. So this is unit vector, very important concept. Unit vector means unit magnitude and direction same as the given vector. Right? For example, if I have this vector A vector, right? Then if I say that the direction must be same and this magnitude is 1. So this vector is called unit vector of A. Now unit vector is represented by a cap over the vector. For example, here A cap is the unit vector along A vector, or this unit vector simply represents the direction of A vector. Suppose I want to go to Ajmer from a point outside DPS. What will I do? I have to ask the direction. So I'll ask someone. That person will come out of the DPS, stand in front of it, and will tell me, look, you have to go straight away on this road. That person will not travel with me to Ajmer. That person will simply direct it. So what is unit vector? It gives only the direction of the given vector. So you can say that when you are writing a vector is written by magnitude and direction. Right? So how will I write it? Magnitude of A into direction of A. Yes or no? So this way I can write a formula of unit vector like this. A vector upon magnitude of A vector. Right? So this portion which is having unit magnitude and direction same as A vector is the unit vector. Right? Then we move on to the concept of parallel vectors. Parallel vectors means vectors along same direction. Right? So that means parallel means same direction. For example, here in this case, A vector is this and B vector is this. So these are parallel vectors. Right? Let's take the case of anti-parallel vectors. These will have opposite direction. Opposite direction means if we have one vector this way, the other will be opposite to it. Right? Then we have another vector called the zero vector. Suppose we have two opposite vectors having same magnitude. What will be the resultant? The resultant will be 0. So that is called a zero vector, having zero magnitude and arbitrary direction. Right? So now we move on to the laws of vector addition. In this video, I'll just take the laws of vector addition. In the next video, I'll take the analytical treatment of vector addition laws. Right? So here laws of first is triangle law of vector addition. So it states that triangle law of vector addition states that when two vectors are represented as adjacent sides of the triangle, when two vectors are represented as adjacent sides of a triangle, right? Its closing side gives the resultant taken its closing side taken in reverse order gives the resultant both in magnitude as well as in direction. So that means we are drawing a triangle and we have one vector like this, other vector like this, and we'll follow the same logic. The first vector, second vector, this is A vector, this is B vector. At the closing side will give the resultant both in magnitude as well as in direction, right? Now the next law of vector addition is parallelogram law of vector addition. So I'm just simply giving you the statement and making the changes in the statement so that the time is saved. So this is the second law, that is parallelogram law of vector addition. What does it state? When two vectors are represented as adjacent sides, or you can say when two co-initial vectors. So I'll tell you what co-initial vectors are. Two co-initial vectors are represented as adjacent sides of a parallelogram. Then its diagonal gives the resultant both in magnitude as well as in direction. So what does that mean? Co-initial means same starting point. What does that mean? That here in this case, if this is the vector A and this is the vector B, these have the initial points same. So these are co-initials. So if I complete the parallelogram, same vector I'll have to draw here because opposite sides of parallelogram are equal. So this side will be equal to this side. So this will be the same vector, B vector, and this will be the A vector. What will be the diagonal? The diagonal will be this. This diagonal will give the resultant of these two vectors. These two laws are very important. You will use these two laws in class 12 to solve many questions. If you are comfortable with these, it will help you a lot, right? So these are the two laws of vector addition. Third law is polygon law of vector addition. That also I'll give you the statement, and then after in next video we'll be discussing the analytical treatment. So the last law is what does this mean? If two or more vectors represent the sides of a polygon, then their resultant is given by closing side of the polygon. Taken in reverse order. Now, how to represent that, Peter? If I have this vector, another vector, A vector, this is B vector, this is C vector, this is D vector. So these are the four vectors which are represented as adjacent sides of the polygon. So the resultant will be given by this closing side taken in reverse order. So this A plus B plus C plus D vector is the closing side of the polygon taken in reverse order. That's all about the laws of vector addition. Then after we will do the analytical treatment. This is all for now. Thank you so much.